So in last chapter we looked to see how a coal fire power plant works and the different components of the coal fire power plant. Well, here we're going to look at a nuclear power plant and the different components of producing energy with nuclear energy. So if we start over here, here's what the magic happens. We have here our uranium fuel element, which are the fuel rods, and then the control rods, and this is where the heat is produced. So they cause a nuclear reaction in these little fuel cells, and within here is a molten sodium or liquid water under high pressure that transfers that heat into a water chamber to create steam and then turn a turbine like you learned in last chapter. These control rods absorb neutrons, so they can be lowered in to slow down the reaction or increase the reaction by taking them out. Because remember, it's neutrons bumping into more uranium atoms that cause the chain reaction to cause the increase in energy. So when that steam is produced, it's pumped through a turbine. That turbine generates electricity. That steam is then funneled back through a condenser that condenses the hot water into cold water, because there's cold water pumped through these tubes, and that cold or the heat transfer goes into this cool water being pumped in that makes the steam that was steam turn the turbine back in a liquid that can be cycled back through the system. So we've got our reactor core, we've got our reactor core, we've got our heat transfer to make steam, turbine that turns, that generates electricity, flow of electrons, and then we have our condenser. Very similar to our fossil fuel plants. So looking at another diagram, you can see we've got a reactor core, heat transfer, turbine, generator, condenser, but one extra thing it has here is the cooling tower. And where the condenser pumps in the cool water to cool down the steam, that warm water, because when the heat transfers to the water in the pipes, that warm water is sent to a cooling tower. And how this works is just based on gravity. So as the warm water rises, it condenses and eventually falls down through these pipes as it's cooled, which helps cool the other warm water coming in. So if we look how that electricity is generated, nuclear fission creates heat inside the reactor, heat transfers into a steam generator where steam is formed, steam turns a turbine and a generator which converts steam into electricity, steam routes to the condenser, cool water removes the excess heat, condensing the steam into water. And then finally, when water is pumped back to the steam generator for reusal, or to be reused. This is what it would look like from an outside view. So when you see the nuclear power plants, you see the big concrete domes. Well, that's where the nuclear fission is occurring. You got your reactor cores inside there, and then you have your generator and turbines outside. Turbine is just the thing that spins because the heat or steam passing by it. Generator generates electricity. And then your cooling tower, the big things. So those big things and that stuff coming out is just water vapor. In a coal power plant, the same thing. Those big cylinders is where the just water vapor is coming out. It's the smaller cylinders where carbon dioxide is flowing out. And then you can see all the water, how it's transferring through. So one more time, let's make sure we've got all the different parts. We've got the reactor core. We've got the reactor vessel, which holds the reactor and the heat transfer. We've got the control rods. All right, those are the things that absorb neutrons that can increase or decrease the amount of heat that is produced by slowing down or increasing the fission reaction. Steam generator, which got here. The turbine, which is not shown here, which is the thing that spins because of steam going passing by it. And then the condenser, what cools down the water to be transferred back through. So other than a conventional nuclear power plant, we also have these power plants called breeder nuclear fission. And what the breeders do is it takes this U-238, which is the unusable form, and it converts it into plutonium-239. And I'll go back real quick. U-238 is not usable. What form is usable? It's 235. And what is the process called when you take 238 and turn it into 235? Enrichment. Very good. So going back to a breeder, advantages is that it makes more fissionable fuel than it uses, and it could supply the country with electricity for 100 years. But the disadvantages of using a breeder is the chemical reactions can cause leaks in the reactor, which is not good. And then plutonium is used in this, in making plutonium, and plutonium is used in nuclear weapons. And plutonium has a half-life of 24,000 years, which means that it takes 24,000 years for that nuclear waste that is used in this reactor to cause half of it to decay. So it takes a long time for the nuclear waste to go away. And here is a handful of plutonium, one of the first atomic bombs, and then also looking at the element plutonium.